Hello guys, welcome to East Coding. In this video, we are going to see the Leetcode problem number 70, climbing stairs. Let's get into the problem. So the problem statement is, you are climbing a staircase. It takes n steps to reach to the top. So each time you can either climb one step or two steps. In how many distinct ways you can climb to the top. So this is all about the problem. So now let's get on to problem definition. So the first step before solving any problem is to define the problem clearly. So problem definition, this is the first step. So the input for this problem is nothing but total number of steps. So to reach the top. So number of steps to reach the top, which is n, which is number of steps to reach the top, and the output is nothing but number of ways, total number of ways in which you can reach the top. To reach top, so this is it. These are the input and output. So they have also given us other condition, which is from one step you can climb either one step or two step. So one step or move can be consisting of one step or two step. So this is our other condition. So that's all about problem definition. Now let's get into the approach. So second step is nothing but approach. So you can clearly see that they will be giving us steps. So let's say one, it's initially considered for 5 steps. So this step 1, step 2, step 3, step 4 and step 5. So yeah, this is the fifth step, and top is nothing but here. So this is the top. So there are 5 steps, and this is the top of top. That is the target to be reached. So the number of ways in which we can reach the target from 5. That is step 5 is only one. So we can only move one step to the up, and we cannot move two steps since there is only one step possible, because it will be there will be no steps apart from the last step. So we can reach only to the target in the only one way. So when we consider moving from step 4, we have two possible ways. So first move is to jump one step, and the second move is to jump to next step directly. So this is move 2 and move 1. So there are two possible ways. So from 4 we can again jump 1 to reach target, and let's consider 3. So number of ways in which we can reach from 4. So let's note the number of ways here. Number of ways to reach number of ways to reach the top. So from this step we have already calculated that one. So from step 4 we can move one move or two move, right? So from one move we can again have the number of moves from 1. So it's nothing but from fifth step we can move to the top in one way. So first step plus second step will lead to only one. So this 1 plus 1 is nothing but the first one is the number of ways in which we can reach the target from the fourth step. So current step in one move. So let's say this has one move and this has two move. So in two move and one move will be one. So now let's go down to the third step. So now what we are going to find out is number of ways in which we can reach the top from third step. So it's nothing but one move. For third step we need to calculate one move and two move and add them. So for one move we'll just move from third step to fourth step, and in two move we'll move third step to fifth step. So in the first move we can clearly see that we'll add up the number of possible ways from 4 which we have pre-calculated. So it's nothing but one move is nothing but number of ways, let's say number NOW, which is number of ways from 4. So 4 is nothing but one move, and number of ways which is, let's say now NOW, of 5, fifth step. So which is nothing but 3 plus 1 and 3 plus 2, the first step and the second jump. So when we calculate that, so here the answer is nothing but 2, here it is 1. So number of ways from 4 is 2 and number of ways from 5 is, so these two are being added here, and finally we'll get the result as 3. So we are storing this 3 as number of ways to reach top from third step. Now we'll go to second step. So for second step we will do the same process. That's nothing but the number of ways when we move one step, and the number of ways when we move two steps. So we're going to add them up. So for first move we'll just move to third. So it's nothing but number of ways to reach top from third step, and when we move two steps from second, which is 4. So number of ways to reach from 4, we'll add this. So number of ways from 3 is 3, which is here, and number of ways we can reach the top from 4 is nothing but 2. So answer is 5. So we are going to put the 5 here in the second step. And when we come to first step we can move. So yeah, this is over. Now we are moving to first step. First step we need to find the number of ways. So it's nothing but one move in the from the first step we can move one move or two move. So we can see that well, when we take one move we'll reach the step 2. So we need to find the number of steps, number of ways to reach the target from step 2. And when we take two steps we'll be reaching uh, step number 3. So we'll find the number of ways we can reach the target from step number 3. So we'll add them up. So when we add them up we'll get 5 plus 3. So 5 plus 3, which will yield us the result 8. So we'll be storing 8 here, and we have successfully stored every value. And finally we'll return the we'll be initially at step 1, right? So we'll just return the value at step 1, which is the number of possible ways in which we can reach the topmost of the staircase when we are initially positioned at step 1. So this is what we are required to find out. So we'll return the answer, that is 8. So this is all about our approach. Now let's get on to the steps to be followed to solve this approach. So before that we'll see the intuition. So intuition behind this problem is nothing but we'll find the from each step from each step from the last. We'll find the number of possible ways, find the number of ways in one move, and number of possible ways which is of possible ways of in two move. When you move two steps, so we'll call this as moves. So we'll firstly find these up and we'll sum them. So for each step we'll be doing this operation, and finally we'll return the number of possible ways to reach top from first step. So why we are going from reverse direction? So in this we are going to follow the iterative approach, so we'll be following from this order, which is reverse. When we go recursive order, we'll go by left to right, but now we are going to use right to left since we are using iterative approach. So there can be two approaches. First is iterative approach, iterative. To solve the problem, there are two approaches: iterative approach, and second one is recursive. So here I haven't discussed about the recursive solution yet, and this is purely iterative approach, which I have mentioned in the approach. So this is all about our intuition. That is, we'll move from right to left, and for each step we'll be calculating number of ways to reach top from the each step, and finally we'll return the number of steps, that is number of ways we can reach the top from step 1. This is all about intuition. Now we'll find the steps to be followed to approach this problem. So the final step is nothing but these steps to be followed. So initially we'll create an array. So why we are creating array? To store each value. That is, when we are at current cell, we need to find the other two cells, right? So we'll create an array, create an array of size 2, sorry, n plus 1. So why we are using n plus 1? Because array will be 0 indexed. So we need to ignore this 0. So for that we will be appending another array index. So when we consider n as say g 1 2 3 4, so when the n is 5, we'll get an array of n plus 1, which will give this value. That is we'll create this, and finally we'll return the number of step at 1. So number of possible ways from 1. So yeah, we firstly create an array of size n plus 1. Our next step is nothing but from n to 1, we need to find the we'll store the array value, which is here of I. We'll iterate I from we'll iterate I from n to 1 and update I as error of I plus 1, which is one step, and for two step, which is nothing but I plus 2. So when we are at last step and also the last before step, our value will be nothing but this will go out of bounds. So in order to handle that, we'll write the base case. So this is what we are going to do, and finally we'll return error of 1. So error is nothing but number of ways from 1. So I'll discuss about the base condition. So we can see that let's say we have only one step. So these are the corner case. So when we have only one step, the number of ways we can reach to top is nothing but only one. So one. When you have two steps, number of faces for this it will be one, and this it will be two. So number of ways when you have two steps is nothing but uh, from this is wrong approach. So yeah, when you have two steps, just when n is equal to 2, you have two steps. So from first step, so from for second step we can reach the target by one step, and from first step we can reach the target by two ways, which is one move and two move. So for one move we'll add one along with the value at along with 1. So we'll have 1 and we'll store this. So initially we'll create an array and store these values. So we'll store these values and find the other values by using the formula. So from other indices we can store value by adding other two indexes, that is I plus 1 and I plus 2. So we'll just fill the last two values. So if, yeah, initially we'll fill the last two values, and other values can be found out by this approach. And so we'll update from n minus 2 to 1. So yeah, this is all about our steps, and now we'll find the time complexity. So the time complexity of this approach is nothing but big O of n, and the space complexity is nothing but big O of n. So this space complexity can be reduced to big O of 1. Yeah, and I'll discuss how we can reduce the space complexity in our coding section. So now let's get into the coding section. There you'll get the clear idea of how to code this solution. So here we'll create an array. Let's say now this number of ways as of n plus 1. So for in initially we'll check for the base case. So if n is equal to 1, the number of ways will be 1. So for 1 and 2, so if let's say if the n is less than or equal to 2, we'll return n. The step, the number of n is equal to 1 and n equals to, for all these cases we'll return the same n, and for other case we store the final value as 1 and n minus 1 as 2. So why we are storing this is nothing but the number of possible ways we can reach to the top from nth step is 1, and the number of possible ways to reach the target, that is stop, from the step before the last step is nothing but 2. So as we have discussed in the approach, so we'll initially store these values, and finally we'll iterate from n minus 2 till first, and we'll just add of I plus 1. We'll move from for calculating number of ways from ith step. We'll sum up the number of possible ways from in one move, which is number of ways from I plus 1, and number of ways from I plus 2, which will give us the value of number of steps, that is number of ways when we go two steps further. So finally we return number of ways from the first step. So this is our approach, and now let's check with the test case. Working fine. Let's submit it up. Yeah, accepted, and it is faster, but it is slow. I mean, it is using some memory, quite high memory. So how can we optimize this? So this approach takes the go of time space. So in order to reduce this, what we can do is from each time we just need the next two values, right? So instead of this, we'll have two variables, which is first variable is nothing but two move step. So two move, and then again second is nothing but one move. So number of ways when you when you have two moves, and number of ways in one move. So we'll have answer variable as 0 initially, and for each time answer is nothing but two move, so one move plus two move, and we need to update the one move to two move. So two move is updated to one move, and one move is updated to answer. So finally we return the answer. So yeah, let's take this up. Working fine. Let's submit it up. Yeah, accepted. And that's all about this video, guys. Thanks for watching this video and have a great time.